Let's now find intercepts algebraically. Now, it does go on to say that this works for any kind of function. So even though this says, given an equation for a line, if I'm given an equation of any type of function, this is how we find our intercepts. So given an equation of a line, to find the x-intercept, if there is one, we're going to let y, or put in red f of x. We should know that those mean the same thing, but just in case, we're going to let y or f of x equal 0 and solve for x. And so then to find our y-intercepts, again, if there is one, do the opposite. Now let x equal 0 and now solve for y or f of x. Now, at the end of this example, I'm going to go over this right here. So I'm going to skip this for right now. And let's go to example 3. So example 3 says a new car is worth $48,000, is depreciating in value of $8,000 per year. The mathematical model, which describes the car's value y in dollars after x years, is y equals negative 8,000x plus 48,000. And that should make sense. This is our slope, and because it is depreciating, it's a negative 8,000. And so we can plug in whatever value of x to figure out what it is worth, but it started at this amount right here. So part A, I want you to find the x-intercept. So to find the x-intercept, we're going to let y equal 0. So in place of this y, I'm going to put 0 equals, and then the rest of my equation. So now solve for x. So first thing I'm going to do is subtract my $48,000 over. And actually, I don't want to do that. I typically like to get my variable to the other side. So I'll save us a step. I'm going to actually add my 8,000x over. I'm going to move that whole term over there. So that will cancel. I'm going to be left with positive 8,000x equals 48,000. And now divide by 800. And I will get x equals this. So it goes on to say, describe what this means in terms of the car's value. So we plugged in a 0 for y. Y was representing dollars, so $0. And then we found x to be 6, and x equals the number of years. So let me go ahead and do this, but in 6 years, the car will be worth nothing or $0. And that is what that means. Now B, we want to do the opposite. Now we want to find the y-intercept. So to find the y-intercept, we need to let x equal 0. So I'll take this equation here. I'm going to put a 0 in for that x. So y equals negative 8,000 times 0 plus 48,000. Well, 0 times anything is just 0. So 0 plus 48,000 means my y equals 48,000. Goes on to say, describe what this means in terms of the car's value. The car's initial worth was $48,000. Part C, use the intercepts to graph the linear equation. Because x and y must be non-negative, limit your graph to quadrant 1 and its boundaries. Okay, so my x is in years. So here is my x-axis in years. Let's go with the black right here. In years. And we know it's going to cross right here at 6 because that was my x-intercept. And then my y-axis is in dollars. So this is representing the car's value. And my y-intercept was 48,000. So why is it saying that x and y must be non-negatives? Well, my years, I can't really go back in time, right? If we could, we could invent a time machine and that'd be really cool and we could be rich. But we can't go backwards in years, so we can't go beyond 0. Can't go beyond either today or when it was initially bought. And then my car's value, it can't go below, right? So you can say that, yes, you gotta buy a new engine, a new transmission, and those are literally the only 2 car parts I know. But like when you go to sell it, you're not going to say, hey, take my car and I'll give you $2,000, right? It's not going to cost you to get rid of it. So my car's value is not going to go below $0. So we want to keep it to a positive x and a positive y. And so if I find my intercepts, all I do is I plot those 2 ordered pairs. And then I can pick up my ruler here, connect the 2 points. And so here would be my graph by using the intercepts to graph it. Now to go back to this right here, this is just something useful for kind of in the future. Okay. And how do I want to do this? All right, so if we wanted to find the intercepts, the first thing it says to do here is to graph your function. First, graph the function with the window that shows all intercepts. So if I come in here and I go to my y equals, clear out my y1, and I'm going to enter in my equation right here. Negative 8,000, so we did hit the negative button first. X plus 48,000. And if I want to graph it in a window that shows all the x-intercepts, well, I've already actually solved the x-intercepts. So I'm going to make my window here go from 0 to 7. I'm just going to go a little bit past it. And then I'm going to do a y of 0 to, let's go 50,000. And I will make this go by 5,000. Scale doesn't really matter, but there's my graph right there. Okay, and actually I can still see I have some of those scatter plots. I'm going to go up here and turn that plot 1 off. There we go. Okay, so line matches. Now, if I didn't know where these crossed, to find the y-intercept, insanely easy. We're going to do trace x equals 0, and that will give you the y-intercept. So if I hit trace and then 0, hit enter, it gives me a y-intercept of $48,000. Or if you even go to the table, you can see that right here. When your x is 0, what is your y? Now looking at this table, I can actually see my x-intercept right here as well. But in case I couldn't see it, because those aren't always going to be whole numbers, what we would have to do to find the x-intercepts of the graph, use the 0 command under the calc menu which is accessed by second trace. We've been here before. So second trace, we've used max and min. Now I want to go to that 0 function. So right here, number 2. It goes on to say that the 0 command gives you the x-intercepts by asking you to choose a value of x to the left of the x-intercept and then a value of x to the right of the x-intercept and pressing enter. So it's going to ask you for your left bound and your right bound again. So if I want left bound, my x-intercept is right here. So if I want to somewhere to the left, this is to the left. I'm just going to go a little bit closer. Okay, maybe right there, but that is to the left of this x-intercept. So I'm going to hit enter. Now it's going to want the right bound. So now I need to go below where you can see these y values are negative. So hit enter, and I get that 0 right there. So just like left bound and right bound, wherever it's crossing, and if I change my window a little bit here, let's just go to, okay, in the context of this problem, if this is my x-intercept, left is anywhere up here above that x-axis. To the right would be somewhere down here below that x-axis.